the top chart shows the number of purchase through different channels such as store and web across each cluster. The bottom chart highlights spending patterns by product category. From the visualization, we can observe that each cluster represents a different type of customer profile with varying preference, purchase habits, and spending behavior. Understanding the cluster allows us to create more personalized marketing strategy and improve customer targeting. Um, and the next, we propose threshold based on a method to help business optimize customer care. Instead of spreading resources to entire local group, we identify truly potential local customer with similar behavior to the VIP group, thereby creating a more effective personalized approach strategy. The first, we normalize the data using min-max scale to bring all features into 0-1 rank, eliminating difference in measurement units across features. The next, we calculated Euclidean distance from each local customer to the central of the VIP cluster. Based on the normalized dataset, we then compute the mean and standard deviation of the distance and apply the following formula. Threshold equal mean k time threshold equal mean minus k time standard deviation. Here k is a changing parameter that allows us to control the number of customer we want to identify as the potential VIPs. Any also customer whose distance to VIP Central is smaller than risk threshold is classified as a potential VIP customer. What makes this method unique is the adaptability, the threshold dynamically adjust to change in the data over time. This gives business a flexible and ultimate way to identify high-value customer, improve VIP conversion rate, optimize marketing costs, and ultimately enhance customer lifetime value. And the last, after evaluating the several models, we selected Thunderfresh as it offers the best performance in identifying potential high-value customer based on behavioral similarity. For this purpose, we focus on the 5 key features: income, material status, family size, and the amount of money spent purchase. When new customers join, especially first-time shoppers, they are initially categorized as normal. However, we can immediately begin analyzing the profile and purchasing behavior and compare it against the patterns observed in existing loyal and big customer clusters. By using random thread to every user similarity, we can detect whether a new customer's behavior align with the high-value segments. This allows business to identify potential fits at an early stage and design more personalized, cost-effective marketing and care strategies. And in conclusion, our approach successfully, we combine clustering, dimensionality reduction, and supervised learning to identify high potential customer. By analyzing customer behavior and applying distance-based threshold, we can detect local customers who are likely to become VIP and also predict the potential new customer at an early stage. This allows the need to personalize the strategy from the beginning. Overall, this integrated framework help improve customer targeting, reduce marketing cost, and increasing long-term customer value. However, one of the main challenges we face is difficult in obtaining sufficient amount of high-quality customer data, which is often hard to collect. This data is essential for ensuring the soberness and effectiveness of the predictive models. And for future research, we plan to apply our research approach to larger and more diverse data sets to further evaluate its performance and improve prediction accuracy. We also aim to explore additional data sources and advanced techniques to enhance customer identification and segmentation. And thank you very much for your attention.
Thank you very much, Takong. Thank you very much for your presentation, improving clustering, reducing noise, and improving the tools, the computer science tools for improving customer experience in our lives in the end, as I said before, is a very important gateway for the future of our society. I would like to ask if from the attendees on the room and online, there are questions to Takong. Please raise your hands or introduce yourselves.
If you have any question, feel free to ask.
Well, I think, Takong, your presentation was very clear. Your tool is a very good opportunity to improve customer experience and the tools to marketing in the consumer industry and others, and improve these uh, electronic systems advancing with the customer experience. Thank you very much for your presentation. And now I would give the floor to the next presenter, Mr. Mr. Telmo Pinto, leading a group of Marco, Valentina, Eduardo, Marcos Reis, and Agostinho Agra, all from Aveiro and Coimbra University. Mr. Telmo Pinto will make the presentation of the Mixed Integra Multi-Objective Programming for Intermodal Supply Chain Design. Once again, we are putting computer science to improve supply chain, to improve our lives, to get goods better, more reliable, more accessible, more cheaper, and improve the life of customers. Please, Telmo, make your presentation. You have the floor.
So much, Palmiro, for introducing myself. Good afternoon. It's a pleasure to address you today and to present our work. Can you see my presentation? Yes. Okay. So my
Yes, we
presentation here
can.
today. Thank you so much. Our presentation here today is about the it's entitled Mixed Integer Multi-Objective Programming for Intermodal Supply Chain Design that we developed in collaboration with colleagues from universities of Aveiro and Coimbra. This research proposes a mathematical model to support the intermodal distribution of soybeans and corn, as we'll see, from the South America to Europe and North Africa, combining both cost efficiency with the sustainability under some sources of uncertainty. First, I will introduce the motivation behind the study, followed by its context and objectives. And I will then present the mathematical programming model we developed and explain how we address the uncertainty through the scenario-based approach. Next, I will share the main computational results and conclude with a discussion of the key findings and future research action that we can draw. This slide highlights the critical importance of supply chain networks for soybeans and corn in meeting demand across Europe and North Africa. We are seeing at the moment a significant shift in supply sources from North America to South America, driven by the availability of more cost-effective and productive agricultural land in South America. To manage these risks, such as political instability, diseases, as COVID outbreaks, and severe weather conditions, the supply chains must be flexible, adaptable, and able of using multiple modes of transport. That's why it is important to have intermodal transportation. Additionally, environmental considerations are increasingly important, requiring the integration of green solutions to minimize, for instance, carbon footprints and others in the supply chain design. Finally, we are seeing the port of Sines in Portugal playing a strategic role as a key hub for distribution and transshipment in Southern Europe and North Africa, making it a vital component of these supply networks. Our study aims to design a supply chain network for the distribution of soybean and corn. It incorporates some sources of uncertainty, factors such as supply, demand, and transportation costs across intermodal routes connecting America, South America, North America, Europe, and North Africa. Our primary objective is focused on minimizing the transportation and distribution costs while emphasizing the environmental friendly solutions by reducing the carbon footprints. And to achieve this, our study uses a multi-objective model to evaluate both the economic and environmental goals under 8 realistic scenarios. Additionally, strategic port locations are highlighted, including Itaqui and New Orleans for supply, and European and other African ports for the distribution. Here represent the key components of our modeling framework. First, the approach uses a objective mixed integer linear programming framework, which allow to optimize multiple goals in an integrated way or simultaneously. The primary objective of our model is to minimize the total routing and distribution costs, ensuring cost efficiency in the supply chain. However, the secondary objective is focused on minimizing the CO2 equivalent emissions from transportation. And our decision variables here represent supplier assignments, proportions, transportation mode usage, and of course the flow quantities. Finally, our model incorporates constraints to guarantee demand satisfaction, allowing or satisfying the capacity limits, accounting for the transformation process, and ensure, of course, valid transportation mode assignments while doing the distribution of goods. Here we outline the key components of our supply chain network, the data that we are providing to our model. Firstly, our suppliers are located at ports of origin in North or South America, including Itaqui and New Orleans. Next, the distribution centers situated at transshipment ports in Europe and North Africa, such as Sines, Lisbon, Rijon, Tarragona, Casablanca, and Antwerp. Our destination countries are primarily in Europe and North Africa, the majority, where there is a consistent monthly demand for soybean and corn. These commodities. Transportation modes here involve a combination of sea, road, and rail routes that connect suppliers, distribution centers, and final destinations in an efficient way. And finally, the products we focus are the two main commodities, the soybeans and corn, each requiring specific processing and transformation steps to meet the market needs. In this slide, I'll try to explain the main decision variables we will use. I will not go into deep mathematical details. First, we need to decide which suppliers serve which distribution centers each month and for each product, for each commodity. And that's what variable X tries to capture. Then we have the variable y, which looks at how demand in its destination country is being met. Z, which tells whether a distribution center is operational for a particular product, for a particular commodity in a given month. And we also include double whether a particular transport mode is being used to move a product from a distribution center to a given destination. Lastly, H deals with the amount of commodities, of products that is being sent from each supplier to each distribution center. Our primary objective, as I said before, is the cost minimization, is to reduce the total supply chain costs as much as possible. The objective function focuses on minimizing all expenses involved in the supply chain. The costs considered include the fixed costs, the transportation costs, also the processing costs in the commodities, and these components contributes to the overall expenses that the supply chain will incur from the origin to the country's destination, to the destination that we are talking about, the demands from some countries. Additionally, the costs function aggregates these costs across all the products over all the months and throughout all elements of the supply chain. I will briefly present the main constraints of our model. Here we have equation 3 that ensures the full satisfaction of the demand in each destination country. So here each demand is associated with a given country. Constraints 4 limits the total flow from each distribution center, ensuring that the amount distributed from any given port does not exceed its processing capacity for a given in a given period. In constraint 5, we enforce that the total outgoing flow from a distribution center after, for instance, any potential transformation of soybeans into meal, for instance, does not exceed the amount that actually arrives there. And finally, constraint 6 ensures that the supply capacity of origin ports is respected, meaning that no port can supply more than its defined limit, its installed capacity. 7 and 8 ensure that a combination of transport modes it's only assigned to a route between the distribution center and the distribution country if the route is used and the distribution is active. This applies to all the products and to all time periods. Finally, the well-known constraint defining the domains of decisions in 9. Our approach is defined using a scenario framework that we use to embed uncertainty into our analysis. We have created 8 realistic scenarios that reflect variations in supply proportions, demand fluctuations, and transportation costs. First, the scenarios consider different supply proportions from North and South America for soybeans and corn, capturing regional supply variability that we can deal. Next, the change in transportation costs are including across multiple modes, sea, road, rail, to account for cost fluctuations in moving this kind of goods. In this slide, we provide an overview of the key components involved in our optimization model implementation. The optimization tool used was the Groby optimizer. Our programming framework is based on Python, using several important libraries for graph analysis, for instance, for geospatial data handling, and so on. The implementation was run on a PC with these components and this type of processor. And in terms of results, the primary supply port that was used in South America, according to these tests, is the port of Itaqui, which serves as the main hub for receiving supplies. In some cases, the port of New Orleans is used as a kind of alternative supply port, depending on the specific scenario. For distribution, ports such as Sines, Lisbon, Rijon, Tarragona, Casablanca, and Antwerp are consistently involved with the exact ports varying based on scenario details. So I'm trying to say that depending of the port depending of the scenario, we'll have different ports involved, which is not surprise. Routing patterns here remain similar across different scenarios through they adjust to though they adjust to reflect changes in supply proportions and transportation costs, for instance, according to the scenario. Here we can say that the port of Sines is often chosen as a key transshipment port due to its strategic location and capabilities. Meanwhile, the port of Lisbon here can function as a vital distribution hub, uh, benefiting perhaps from its rail connections that facilitate efficient inland transportation. Additional ports like Antwerp, Rijon, Tarragona, and Casablanca play important roles in more regional distribution networks. So perhaps the more focus on regional distribution. These ports serve as critical supply nodes, linking supply from the Americas to demand centers across Europe and North Africa. And together they form a kind of integrated network supporting global versus regional trade flows. In this slide, we provide an overview of the annual flows of soybeans and corn. We'll try to highlight the key points about their origins, sensitivity to transportation costs, and the impact of demand changes. We have a lot of results, so here we are just presenting briefly comment. Firstly, more than 20,000 tons of soybeans and more than 50,000 tons of corn are transported each year, with these amounts varying depending on the scenario. The soybean flows mainly originate from the port of Itaqui, which is a significant hub for soybean transportation. And corn flows on the other hand, and more sensitive to changes in the transportation costs. In some scenarios, this sensitivity leads to an increase in North and North America corn supply routed through New Orleans. Finally, when demand increases as seen in scenarios 1 and 2, there is a corresponding rise in the total commodity flows for both soybeans and corn for both commodities. In terms of key factors influencing corn transportation and supply routes, first, due to higher costs associated with rail and road transport, we can see that there is an increased preference for sea transportation routes because they offer cost advantages. The highland transportation costs have shifted the usage of supply ports, notably increasing the reliance, if you can say that, on North American ports for corn supply. Additionally, the selection of distribution ports in the Northern Europe is affected by these cost conditions, and with certain northern European ports gaining more importance. Finally, it is important to note that corn logistics are very sensitive to changes in land transportation expenses, which significantly impact the supply chain decisions. Finally, in terms of results, the port of Sines is well known for its deep water terminals, which provide natural characteristics for maritime activities. Its strategic location allows it to serve countries in the Mediterranean and offers an alternative to the traditional North Sea ports. According to the various model results that we have, Sines is consistently selected across multiple is consistently selected across multiple scenarios uh, for the distribution of soy and corn, highlighting its importance in agriculture logistics. Additionally, there is a strong potential to justify investment, for instance, in grain terminal infrastructure or at this port, which could further enhance its capacity and operational efficiency. Finally, in conclusion, we can derive 4 key contributions of our model. First, it identifies optimal logistic routes by considering demand, supply, and cost constraints, helping decision makers plan efficient transportation paths. Second, the model assists in selecting the best transportation modes and their combinations to minimize both costs and emissions, supporting sustainable logistic practices. And third, it offers insights into strategic port utilization and network design, especially under uncertainty conditions, enable more resilient supply chain planning. Finally, the model includes a scenario evaluation framework that allows users to assess alternative strategies and make informed investment decisions in supply chain infrastructures. So finally, I'm happy to answer if we have any question. Thank you so much for your attention.
Thank you, Telmo, for this last minute's shortage of time. Any questions from the audience online or in the room?
There are no questions from the room.
Thank you very much, Telmo, for your very nice presentation, and we also hope this nice job will contribute to improve our supply chains in the future. I now give the floor to the next speaker. I ask Alfonso if we have someone conducting on the room, or shall I continue to present the next speakers?
Yeah, Professor, we don't have the chair here in the room, so if you can continue from the virtual room.
For sure. So
thank you very much.
Now the next presentation from São Paulo University. So we just talked from Marco paper and Telmo presentation. We talked about the connection between Europe and Brazil, and now we have São Paulo University presenting combining computer vision and artificial intelligence to support rehabilitation of post-stroke patients. This is a job made by Luis Felipe, Gabriel, Juliana, Luis Guilherme, Diego, and José Remo. Please take the floor and make us your best of your presentation. Thank you.
Are you seeing my presentation?
Yes.
Okay, my name is Diego Dias. I'm a professor at Federal University of Espírito Santo in Brazil. And I'm going to present today the paper that was part of Luis Felipe de Camargo, his PhD. He was advised by Professor José Remo Brega from Unesp, Bauru, and co-advised by me. And it's combining computer vision and artificial intelligence to support the rehabilitation of post-stroke patients. So let's introduce what is stroke, understand a little bit about. Those strokes occur when blood vessels supplying the brain are either obstructed or ruptured. We have 2 kinds of strokes, but both of them leads to ischemia and subsequently paralysis of affected brain region. So you can lose movements or you cannot speech. So you have some kind of problems post-stroke. Impacts more men than women. and is among the leading cause of mortality, disability, and hospitalization worldwide. And the early diagnosis and intervention can improve the chance of full recovery. And this research would focus at intervention, not the early diagnosis. I'll show you a little bit about it. And the most stroke survivors experience some form of physical or cognitive sequelae. And when we start early, the rehabilitation process that provides comprehensive treatment is crucial to mitigate the long-term effects, mainly the movement effect. And rehabilitation is also to reduce the impact of disabling condition and to enable individuals with disabilities to achieve full integration in society. And physiotherapy plays a crucial role in improving quality of life in this issue. Here we have some tools in healthcare, what the whole of computational tools healthcare. Integration, we research some integration of computational tools. So we're developing solutions using virtual reality for immersive environments, wearable device for interactive environment in virtual reality. And these personalized treatments monitors patient progress and foster autonomy in rehabilitation. So the integration of these areas, virtual reality, IHC, interface human computing, with AI, artificial intelligence, enhances therapeutic efficacy and contributes to an improvement of quality of life. In Brazil, in the Brazilian context, I don't know what you know about Brazil. I see we have Brazilians here today and a lot of Portuguese native speakers, but Brazil is a really huge country, and the strokes is a problem there also. So you have significant challenges remain, including an equal access of technology. We have a huge country, and the technology doesn't reach everybody. You have lack of integration among healthcare systems and the need for greater investment in research and development. The motivation of this study of the Luis Felipe PhD, it's to anticipate the emergence of new applications and the support in the treatment of stroke patients, particularly in analysis of exercise performance. So we develop applications to collect the data and try to perform treatment to other patients. So in this paper present a study that has a fair literature review and the development of application based on this review. We use some key technologies at our researchers. So computer vision, defined as the field focused on enabling computers to perform vision tasks. We also use the human pulse estimation term technique where a computer aims to detect human movement with applications across various domains. The human action recognition that involves applying video analysis techniques to identify activities performed by individual through observations of the person and their context. So it's really applied healthcare area. In the artificial intelligence here, field of computer science that seeks to simulate human intelligence through technological means. We also focus our study in explainable artificial intelligence, a relative newer area. Since 2018, I think you have been founding something about XAI. That's a subfield of AI that seeks not only to deliver outcomes, but also to elucidate its own purpose and decision-making process. So XAI is really used for explaining RNA neural networks, for example, that are more difficult to explain than statistics models. And as I said to you, our research were two objectives, twofold. So the first one was a systematic literature review with the purpose to gain a comprehensive understanding of the research domain, identifying emerging trends and inform development of creation. The scope of our studies, we collected studies from 2017 up to April 24, 22. So before LLM's advent, before ChatGPT, for example. And the database we searched the papers were ACM Digital Library, IEEE Explore, and CAPES Journal. The CAPES, the last one, Portuguese researchers. The ACM, IEEE, only English researchers. Language and written in English, of course. Here the search string that we have used with the terms deep learning, XAI, computer vision, classification techniques, and so on and others. In our systematic review, we found 560 studies, but after the first filtering, we removed some of them. So duplicate studies, studies that was not in relation to our domain. So we stayed with 532. The second filter after abstract screening is we excluded another 494 studies. So we got 44 select studies. And after a full text evaluation, we exclude another 18 when stay with 26 studies. So our research at the end of our systematic review, we read 26 studies we use for our systematic review. What we try to respond with this review? The most used captured methods, for example. So we have inertial sensors, Kinects, infrared cameras. We have RGB cameras, webcams, smartphones, and others. So we found that the video capture was present in the majority of the studies, 65%, and followed by the use of sensors, IMU sensors. So we have bussola, gyroscope, and this kind of sensors. The most used programming language this application was Python. So I think most because of the artificial intelligence, or using Python or using R language is even most used. But 90% of the authors use Python programming. About the datasets, when we're talking about the AI, we need to use datasets. It's not easy to find datasets, open datasets about healthcare, about body tracking, for example. And research trends, majority of authors use pre-existing datasets, but with camera capture being the most commonly used method, and Python being the most frequent used programming language. Here we have some decisions for our designing. So we use video motion capture without the need of specialized sensors. So for our application, we developed using RGB cameras. We developed our application using Python programming language. If for our application use the our dataset, a rebase. It's called rehabilitation database. And the application purpose was to develop application to chart the rehabilitation sessions to select some joints and parameterize some movements and monitor their progress individually per patient. So the technology stack that we use in our application, we use a MediaPipe, computer vision and AI library from Google to employ convolutional neural networks for body tracking. We also use OpenCV, computer vision library used to draw polygons. So you combine the body tracking of MediaPipe with OpenCV to draw some polygons. I'm going to show you the application why you try to mix them. In hardware, you use a conventional RGB camera. About the movement, registration begin with registering the movement, providing its name in two sets of joints. We have the aspect angle defined by the first set of joints. So what we're trying to store in the limb we're going to use in, for example. The compensation angle defined by the second set of joints, because sometimes we have the movement of a patient who lost the movement. He needs to do this movement, but he cannot do this. Do this and do this to compensate the movement. It's a problem for us, for the healthcare professionals. So we need to get both of them to try to subtract the compensation from the movement. Here we have the support and joints. You have a full body tracking. Here the movement, we have the expected movement in this compensation here. This is the compensation, and how I select the vertex to start the movement. The recording process, once movement is registered and was parameterized, the sessions can be recorded. The healthcare professional, he starts the story, and the computer webcam is activated, and patients is recommended to stand up to 2 meters from the camera when we used to make a full body. And the detected body point joints are displayed in real time before recording starts. So here we have a figure from the application. Green polygons represents the flexibility, what we expect, what we want to measure. In the red one, it's about the spinal compensation. We don't want the spinal compensation, we just want this part. But all the patients do that. Like And about the media pipe, detects body joints, eliminate the need of training a new AI model. So it works really great with RGB cameras. The OpenCV you use to draw the polygons. So that's why we combine OpenCV with media pipe. Here we have our application workflow. You have first the frame selection, select of relevant frames to optimize performance and reduce computational load. We have the object detection, the body parts. Machine learning models identify objects within a frame. The detection tracking and detection merging, when we're trying to merge the media pipe and the OpenCV. And here we have the decision annotation displayed for user, patients, and professionals, healthcare professionals. So we have the data acquisition. The habilitation session is conducted with the healthcare professional positioned in front of the video camera device. The data process, the video is processed using OpenCV for computer vision tasks and MediaPipe for pose estimation for body tracking. The real-time display, the interface shows the video feed, the estimate pose, and the calculated angles in real time. And the data is stored for post-session analysis. So here we have an example of movement. The peak is when you make the movement. So this is a joint angles. So make the movement, put the raise the hand to the rest state. Make the movement again, rest state, make the movement again. So here you have three movements. And the orange line is the compensation. So we need to subtract the compensation from the movement to really have the movement of the patient to see how it's going the treatment, the rehabilitation. Here I have some graphs that expected from the patients. You have the expected movement, the compensation. You can see that after some sessions, physiotherapy session, the compensation is getting lower. That's good. And the angle here is not really good yet, but the compensation is getting lower. We have some improvement for the patient. You have the session playback with avatar. Both the patient and the healthcare professional responsible for the habilitation can watch during the session what's happening using the visualization. And the system also allows to capture coordinates and send to the rebase, the rehabilitation database. It's a database that we have been constructing since 2019. So we have a lot of register there from different limbs, different group of limbs. So we have arms, legs, all the joints. You have been used the rebase to train some machine learning models. And as conclusion, we developed a technological tool to assist in the rehabilitation process of stroke patients. And by analyzing body movements during exercise sessions, the proposed application seeks to support professionals in the field. It's considered that study conduct of our systematic literature review and development of the application have proven relevant to the research area and helps also Luis Felipe with his PhD, his research questions, for example. The application is still at the prototype stage, but includes the key features initially planned, and you have some preliminary results from initial informed evaluation with some professional healthcares from Unicamp, from neurophysicists, and the medicine school. They have been using our solution there. Here we have some futures work, evolve the application. So we need to evolve application, collecting more data. We try now to expand our data set using LLM. So you have real data. We're trying to input new data using ChatGPT, for example, Llama. It's a part of our study. Expand the use of group of healthcare professionals. Most of them are in Campinas and São Paulo, but try to improve. And that's it. Here some acknowledged. This study was part of funding by CAPS from Brazil and CNPq, and also FAPS from Espírito Santo. Here we have also Huawei that was part in funding. This research was part in funding by Huawei in 2021. you start to conduct this research with their support. And that's all. Thank you very much.
Thank you very much, Alfonso, for your very nice presentation. Once again, we see computer science in favor of humanity, in favor of healthcare, in favor, in this case, of the rehabilitation of stroke patients, a very important field of application for computer science to improve our lives in the end. So I call any questions from the audience online or on the room, please. Once again, I think the presentation was very clear. Thank you, Alfonso, for your contributions. And I now call the last but not least, also very important in the field, on the health field.
Yeah. Sorry to interrupt, Professor, yes. But we have a question from the room.
Sorry. Please make your question to Alfonso.
Okay. Okay. No. Okay, no, we can go on. Sorry.
Okay. So we have the next presentation from Adel Al-Solai. Is from the University Prince Nora Blint Abdul Haham from Riyadh, Saudi Arabia, and also is on the field of medical sciences. Is presenting a paper for the early prediction of heart diseases in the primary stage. So once again, computer science improving our lives. Please, fellow colleague Adel, take the floor.
Yes.
Just to prepare the presentation.
Of course.
Okay, just a few seconds. Okay. Can you see the presentation?
Yes.
Okay. Can you see the presentation?
Yes, we can see.
Okay. Thank you.
Hello, everyone. My name is Hadil Al-Solay. I'm assistant professor at College of Computer and Information Science at Prince Noura Bint Abdulrahman University, Riyadh, Saudi Arabia. I'm glad today to present my paper, which is about the application of machine learning algorithm to predict heart disease. The table of content, this is like a summary of what I will present today. First, I will shed light about introduction of prediction heart disease. Then I will go to with the research questions. I identify some of the research questions, and this paper try to answer this research questions. Also, I will provide the objectives of this paper. Then I will go to the related work. I collect some paper that related to the predicting heart disease. Then from this paper, help me to design the methodology about the prediction of heart disease using the machine learning. Then finally, I will go to the result and discussions, and finally the conclusion of this work. For the introduction, detecting heart disease early is very important for better treatment and saving the lives. For this reason, I used machine learning because it's offer a new and effective way to improve how we predict heart disease. Instead of waiting until the patient is becoming have heart disease, no, machine learning helping in advance to detect the heart disease. Study often used feature like gender, age, heart rate, chest pain type, and cholesterol level, because these features is related to this disease, heart disease. Main risk factor for heart disease is high cholesterol, diabetes, smoking, obesity, family history of the heart disease, and finally, high blood pressure. The main challenge is predicting heart disease based on these features is difficult to do manually. For this reason, which is why machine learning tools are helpful to detect this disease. So this is the research questions. First one, which attribute turn to be the most important attribute in predicting heart disease? So I will identify the most important attribute or features in the predicting heart disease. Then the second questions, does the performance of feature selection increase the accuracy of the predicting algorithm of the heart disease? So I will use like a feature selection, and I will see what is the impact of these feature selections. Also, the third question, does the performance of hybrid algorithm, I used vote algorithm, which is kind of hybrid algorithm, increase the accuracy of single algorithm of the heart disease? Then I will go to the last question, which is does the performance of hybrid algorithm vote better than the model used by selected previous studies in predicting heart disease? So I compare my model vote with the previous study that used the same data set. So the objective of this study, the paper aimed to increase the prediction accuracy of the heart disease by comparing between the following. First, model created using feature selection and without feature selections. Also, single algorithm like Bayes network, neural network, decision tree, and GRIP, and also hyper algorithm like vote. Then the best model from this algorithm, I compare it with the previous selected studies. Related work of predicting heart disease, 9 relevant studies on heart disease prediction were selected. For each study, we identify the dataset used, number of the features, and record pre-processing techniques if the paper used any pre-processing or cleaning dataset, and which evaluation matrix that used, and the last thing, algorithm applied. So I summarize all this information in the table to compare between this information and also to compare the result at the end. So the main gap from aforementioned table that in the paper are determined as the following. So I found these 3 gaps in the table. The first one, most of the study have been used data set that include a few number of records. It's about 300 records. So this is the main gap. The second one, a limited number of study have been performed feature selection techniques. And the last thing, relatively a few study have been created hybrid algorithm, where the several study have been created single algorithm. And we know almost the hybrid algorithm increase the accuracy predictions. For this reason, I designed the methodology to resolve this gap in the previous selected study. So I collect, I integrate 5 data sets. All these data set is publicly available. And I create the new data set. It's namely heart disease data set. Then I apply the pre-processing technique. The first one, remove duplicate records, because because they have like 5 data sets. Some records are duplicated. For this reason, we removed this. So I ended with about 900 records. Then I have carried out 2 data sets. Some data sets, the first data set is without applying any feature selections, and the second data set I apply to feature 4 feature selections, and I integrated the result of all these 4 feature selection to create the data set. So the first data set is included 11 attributes, and the second one, it have 8 attributes. So I apply machine learning techniques in both these data set. First, I apply the single algorithm, which is our Python network, neural network, decision tree, and algorithm. Then I create vote. As you know, vote is it's like integrate algorithm. I use all these 4 single algorithm to create a vote as a base algorithm in the vote, which is a hybrid algorithm. So this is the methodologies of this study. The result and the discussions of these, I connect each research questions with the result. So the first research question, which attribute turn out to be the most important attribute in detection heart disease? When we apply the first, the 2 feature selection, which about that like a subset method, these feature selections take like a subset of the most feature selection that affect on the model, best first and greatly stepwise. And as we found some attribute they didn't select it, which is resting PR and fasting PS and resting ECG. These 3 attributes is not selected by subset method. And the second method, it's about a ranking method, which it's give like each attribute ranking. As we know, it's almost the same. All these 3 attributes, it also has lowest ranking. So I integrate the result of all for these attribute, and I removed these 3 attributes from the data set. So now I have 2 data sets, one with all the features and the second one without 3 features. Then the second question, which is about, does the performance of feature selection increase the accuracy of a prediction algorithm of the heart disease? The answer is no, is not too much improvement when I remove 3 feature selections. As we see when we compare the predictions model before and after removing feature selections, we didn't see much improvement. And the second question, does the performance of hybrid algorithm increase the accuracy of single algorithm of the heart disease? So I compare I compared the vote algorithm with all these 4 algorithms, and as you see in the last columns, a vote algorithm, it has like higher accuracy prediction in the all of the evaluation measure, which are precision, recall, F measure, AUC, and accuracy. So the answer of this question is yes, the hybrid algorithm increase the accuracy of the single algorithm. Also, I compare the vote algorithm with the previous selected study, and the answer is the performance of the current study, which used vote algorithm, is better than previous selected study in most evaluation measures. Some evaluation measures in some study, they have like a little bit more than the result, but in most cases, vote algorithm, we can conclude it's like a good prediction model to predict in predicting heart disease. So the conclusion of this paper, the result of our empirical study showed that the prediction performance of vote algorithm is better than other single algorithm. And the second thing, the performance of the vote algorithm outperform the previous selected study in most evaluation measures. And the last thing, the application of feature selection, 8 attributes have been selected by all the methods that used for the feature selection, which means only 3 attributes have been removed, namely resting P, P, fasting PS, and resting ECJ. The deleting of this attribute does not really affect on the performance of the prediction algorithm. So thank you very much for your listening. And if you have any questions, thank you.
Quick question.
Yes, I have the questions in the note.
Perfect.
Okay.
For the presentation, I was wondering what was the criteria was for removing these features.
I used like most feature selection technique, and that's from two types.
That was did you kind of deleted these features because of the certain threshold that you have in the code, and how you decided the threshold?
The code of the feature selection, they didn't select all these three attributes. This feature selection is already in the Weka tool, is already in the Weka tools, and the algorithm is built and already built in the Weka tool. So I just use these feature selections, and it's removed this attribute. But it is two kind of feature selection: subset and ranking. And all these type, they have the same result. Remove this one does not affect. But when I apply the models, the result is no, it's not improvement by removing this. So it's the same. Yeah. So, but some paper, some studies, feature selection is helps, but other study feature selection is not necessarily help to improve, the prediction. Yeah.
Thanks.
Thank you. Do you have another questions? In the room, no questions. I don't know if anyone in the online, they have any questions.
So thank you, Adel Al-Salai. Thank you very much for your presentation. It was a great presentation, also a nice contribution to healthcare, to early prediction of heart diseases. I hope your contribution to science will become, as all the other presentations before, will improve our lives, will improve world. And this is why computer science is very important. Computer science helps the machines, help the computers, which are the machines if we don't put them intelligence inside. So it's the applications, it's the computer science that makes these machines really helpful, really improving our lives. And so thank you very much for your contribution, and we hope your science will progress humanity, as well as the other presenters before, also with their contributions. Thank you very much all. So we finish here the room H, session 2H of this nice conference of once more the 25th International Conference of Computer Science. Thank you all for your participation. See you soon on next opportunity.
Professor?
Yes,
Can you hear me?
Yes.
Just a courtesy, if you could fill up the evaluation template, since you have stepped in as the chair of this session, since you have all the qualification for evaluating the papers. So can I send you the
Yes,
link?
You have my email, belmiro@universityaveiro.pt.
No, I don't have your email.
I will put it now on the chat room.
Okay, thank you very much. Okay, thank you very much.
Thank you very much, Alfonso. So see you soon.
See you soon, and enjoy the ICCSA conference.
Of course.
Thank you very much again.
Alfonso, sei online?
Okay, good afternoon, everyone. We are ready to start with this session of the ICCSA conference. Thank you all for your participation. Now I'll leave the floor to Professor Nadia Neja from the State University of Rio de Janeiro, who is the chair of this session. So thank you very much again. And Professor, the floor is yours.
Hi, everybody. I'm Nadia from the State University of Rio de Janeiro. I'll be sharing your session today. And I'm going to give 15 minutes for the present and 5 minutes for the free question, if any. Okay? The first presenter is Mama. Mama, you're there?
Just.
Mm-hmm.
She's not there.
Mama? Yeah, she's not there. Oh, look here. No, he's not here. Oh, he's here. Mama? How are you?
Yes.
Do you hear me?
How? Yeah. Yes, I hear you.
Okay. So the first presentation is done by Mama from Algeria, and the title of the presentation is Using Differential Evolution for Minimal Routing in Network on Chip with 2D and 3D mesh topology. All right, Mama, you have the floor for 15 minutes. You can start.
Yes. Yes.
You can share your presentation. Mm-hmm. Okay. All right.
Can I start?
All set.
Can I start?
Sorry?
Can I start?
Yes, you can start.
Hello, everybody. My name is Boughara Muammar. I am from Algeria, and I will present you my work with the title Using Differential Evolution for Minimal Routing in Network on Chip with 2D and 3D Mesh Topology. We start with the content, introduction, network on chip, the routing problem, differential evolution optimization, and test and result, and we finish with conclusion. System on chip is a chip that integrates a complete system in one chip, but the number of integrated components increase requirement of 2D applications. The design of a system on chip is focusing on communication more than computation. So communication in network in system on chip has become an important research topic due to the increase of processing power and the speed of data application. Researchers are working to establish new means of communication between these components. The goal is to provide communication between this component in system on chip using a new structure. This structures called network on chip. Network on chip is similar to a general network, but with limited research. Network on chip offer a more efficient design by enabling multiple components to communicate. This architecture improves scalability, reduce communication, and enhance over system performance. A network on chip is designed to run an application, a specific application. A specific application can be represented by a set of tasks that can be executed sequentially or in parallel. The component of network on chip is intellectual property. It's a general or special purpose such as processor, memory, or DSP, and also have network interface that they ensure interface between the processor and the router, and also the router its rule or route data from source to destination using a protocol. To organize this component, we use a topology. The topology used in this work is 2D, but when the number of the component increase, we must reduce the area with stacking many 2D topology to form 3D network on chip. This is an example of 3D network on chip. To design a network on chip, we must follow many steps. These steps use an optimization that first is assignment of task and IP mapping and the routing of data. In this work, we focus in routing data. The routing data, the problem of routing data is to find a route between a source and destination. This is an example of routing, and we can find many routes between the same source and destination. To design this problem, we must create a solution. The solution is the number of routes between the source and destination, and we try to find one route between the same source and destination in every sources and destinations. For this example, if we choose one route between source and destination, and every source destination has many routes, we have 60,000 solutions possible, and we must try to find the best solution. And in this work, the best solution is based on congestion. The goal is to minimize the congestion between source and destination. In this example, we have many data communicate forming a congestion, and here the same solution without congestion. To find the best solution, we must use a meta-heuristic algorithm. This work we based on differential evolution algorithm. It is an evolutionary algorithm proposed by Price and Stern in 1995. Is considered as one of the most powerful evolution algorithm for real number function. The process search in this algorithm is based on mutation. We began by the first step is initialization, that initializes the population used, created randomly, and also initialize the parameter of the algorithm. After that, we use the mutation step, the mutation disturbing the population with the mutant vector PEG for each individual in the population at one generation. The mutation operator can be generated using a specific strategy. Many strategies are used, but in this work, we use the strategy based on random, the first one. After that, we have the recombination step or crossover step. The crossover improve the diversity of the population being applied after mutation phase. The crossover use a mutant vector to exchange its component with the target vector. After that, the final step is the trial vector. It is evaluated according to the objective function and compared with its corresponding of the target vector in the current generation. If the trial vector is better than the target one, the trial vector will replace the target. Otherwise, the target will remain in the population. Here, if the trial vector is better than the target according the function objective. The function objective is based on congestion. In this slide, the main step of the algorithm. And to apply the algorithm, we used this parameter. We choose 200 iteration, a swarm of 100 individual, a scale factor equal to 0.5, crossover coefficient equal to 0.9, and the mutation strategy used is based on random. To test our algorithm, we must use traffic patterns. Traffic patterns can be classified in deterministic or random traffic pattern. In deterministic traffic pattern, we have three deterministic complements, transpose 1, transpose 2, and in each deterministic traffic pattern, we have the source node and how to calculate destination node from 2D mesh or 3D mesh. But when we choose random traffic patterns, each source sends data to a random destination. We have also random traffic, random and hotspot. Some specific destination receive more traffic than other. We call it hotspot, and local, that if each source send data to one of these nearby destinations. After the result, we try to simulate our result to a simulation. We used Noxim Access routing simulation, and the parameter used in this simulated is network dimension 5 to 5 in 2D, 3 by 3 in 3D. The packet size is 8. The virtual channel 4, warm up 1000, simulation time 2000 cycles, and we try to compare our result with particle swarm optimization routine and two other static routine x, y, z and odd even. Here the result obtained in random in 2D and 3D, and we remark that average packet latency obtained by our algorithm differential evolution is better than PSO and XY and odd even. Also, the same in hotspot, DE algorithm give better latency of result according to the other algorithm. But in 3D, DE and particle swarm and XYZ routing algorithm give approximately the same packet latency. In local, we have the same result obtained, but 3D DE give better algorithm than other. In deterministic patterns, in transpose 1, DE and particle swarm give the same result and better than XY odd even, and also in 3D and 2D. In transpose 2, also we remark that DE and particle swarm give better results than other. And in complement, we remark that particle swarm outperform DE in 2D, but in 3D give the same result. In summary, the proposed algorithm routine give lower latency compared to traditional routing methods. In 2D mesh topology, DE outperform X, Y, and odd even compared to particle swarm. In 3D mesh topology, the proposed algorithm outperform X, Y, Z, odd even, and also particle swarm optimization. In conclusion, this work proposed a new routine algorithm for network on chip based on differential evolution. We use to minimize congestion in 3D and 2D topology. The tests were performed using simulation, using generated deterministic traffic and random traffic. For future work, we plan to use other computation algorithms and exploring other meta-heuristic and integrate real application task graph and also evaluated on other parts. Thank you for your attention.
Thank you, Mama. Do you have some question? Someone has some question? I just have one. How do you set the parameters for the algorithms? For the DE? You have lot of parameters. How do you set them? How do you choose them?
For the first one, for the number of population and the number of iteration, we try many parameters, and the best one is when we choose 2000 and 1000. But the choice of strategy like random or random 1, random 2, best 1, best 2, current to best. We begin by random, and we try to in future work to simulated this other strategy and compare it with the random.
Okay. Okay, thanks, Mama. Now let's thank the speaker. Okay, next presentation is done by Luigi. Luigi, you're there? Luigi?
Hello. Hello, everyone.
Hi. Can you share your screen, please? So
Yes.
Luigi is going to present a method for SLAM, simultaneous localization and mapping. Okay, you have 15 minutes to present your work. You can start.
Okay. Thank you, Professor Nadia. Hello, everyone. My name is Luigi Ribeiro. I'm from Brazil. Today, I'm presentation to my work Mars Islam, Mark Assisted Region Scanning for Simultaneous Localization and Mapping. Presentation summary as introduction, methodology, result, conclusion, and finished future work. So, what is Islam? What is its important? Okay, simultaneous location and map Islam is fundamental for mobile robots. Okay, it's allow robots and other autonomous system to move through unknown environment by increasing a map while also track the OE position on it. This ability is important for many applications, such as self-driving cars and space exploration space mission, okay? But one of the main challenges in SLAM is to make sure the map is complete and efficient, especially in complex environments where traditional methods can leave gaps and reduce repeat paths. Okay, we propose Mark assisted region scan for Marslan. This new approach uses virtual marks to help the robot find and exploring areas that have not been mapped yet. The goal is to reduce resource use and improve the accuracy and the completeness of the map. Marslan works well in completely unknown environment and can adapt in real time, okay? By using mark, age, and distance to plan the robot's path. The method makes the exploration more organized, completing, and efficient. The Mark Assist Region Scan algorithm helps the robot full exploration on no environment by using virtual marks based on LiDAR sensor data. At the beginning, the grid map is defined entirely unknown, and empty lists are created to store the robot pose, the markers, the LiDAR readings, and the path. The robot starts with a full rotation to scan the area, update its state, and add markers in places that are not mapped yet. Then enters a loop. This loop, as long as there are markers, the robot selects a target, moves to the point, updates the map, and remove any marks in areas that we already know. New marks are continuously added as new regions are identified. The process ends when no marks are left, indicating that the entire area has been mapped efficiently and systematically. The center of our method, this is mark list update, divided in 4 steps. Step 1, identification of few areas. Step 2, mark inclusion. Step 3, map update. Step 4, mark remove. In step 1, identification of few areas, marks are created based on readings from the LiDAR, a sensor used by the robot to map the environment. Each measurement provides the distance to the first obstacle detected in the respective directions. The LiDAR has a maximum range, and measurements beyond this limit are not considered. During the robust movement, at each registry pose, all LiDAR measures are analyzed to identify obstacle-free areas. In step 2, mark inclusion, these marks serve as indicators of an exploration regions, guiding the robot throughout the map process. Mark addition is a crucial step. Marks are placed in areas identified of free space. To avoid placing too many marks close together, a new mark is only added if there isn't already only nearby, based on minimum distance. Step 3, map update. When navigation to the target mark, the maps are updated with new information get by the robot. In step 4, mark remove. Remove marks is thus as important as addition 10. This step keeps the map up to date and show only the areas that still need to be explored. As the robot moves and maps new regions, any marks that are now inside explored areas are removed. A marker is removed when its all cell and all nearby cells are not longer marked as unknown on the map. Application example. In this video, we present an example of the Mark-Shalom method in action. We can see that the robot movement is fully guided by virtual marks placed in areas not explored yet. As the robot moves, the list of the marks changes in real time. New marks are added when new regions appear, and older ones are removed once those areas are mapped. This experiment shows that the method can explore unknown environment efficiently and can also detect when the mapping is finished. Just a minute. Okay. Sure. Results. To validate Marshall, we conducted extensive experiments in 2 distinct virtual environments, Map 1 and Map 2. Our goal was to analyze Marshall performance on different conditions and compare it against 2 benchmark navigation methods, a standard zigzag route and an ACO optimized route. It's crucial to highlight a key distinction here. While the zigzag and ACO routes were simulated with prior knowledge of the map to distribute markers, Marshall operates autonomously in completely unknown environment. Okay? Map progress on map 1 for its methods. zigzag, ACO, and Marlin at 0, 50, and 100% map completion stage, okay? Here, map progressing map 2 from its method, zigzag, ACO, and Marlin at 0, 50, and 100 map completion stage 2, okay? The result, in map 1, Marlin reduced the number of the poles by about 51% compared to zigzag and 70% compared to ACO. In map 2, the reduction were even better, around 68% and 49% respectively. For simulation time, Marlin was about 57% faster than zigzag and 10% faster than ACO in map 1. In map 2, it was around 54% faster in zigzag and 29% faster in ACO. These results show that Marlin clearly performs better than traditional methods. It reduces both the number of the poles and the time needed for mapping, and it does all of this without using any prior information about the environment, okay? So, Marlin represents a significant advancement in optimizing SLAM for unknown environments. Our method uses Mark to ensure efficient and accurate mapping, systematically identifying and tracking and exploration regions while minimizing critical resources, such as the number of the poles taken by the robot. Our experimental results consistently demonstrate Marlin superior performance compared to both zigzag and ACO methods, achieving high map completeness and drastically reducing the number of the poles in total simulation time. Marlin stands out as a robust and versatile solution, particularly valuable for autonomous exploration missions where no prior map data is available. In future work, this point improve sensor configuration, refining market placement strategies, test performance in real world, explore alternative sensor types, adapt Marlin for high dynamic environment, integrate with real-time autonomous navigation system. Okay. I would like to thank WERJ, UFRJ, CAPES, and FAPES. And thank you very.
Thank you, Luigi. Any question? Luigi, I'm going to talk very slow. Does your algorithm, the performance of your algorithm, depend on the initial position of the robot?
No, not depend.
Have you tried different initial position and compare the performance?
I don't understand, Professor.
Have you tried starting the robot in different places?
Yes.
And compare the performance?
No, no compare. But good questions.
You should do that to see if the initial position of the robot impacts the performance of the navigation. Okay?
Okay.
All right. Thank you. Let's thank the presenters.
Thanks so much, Professor.
Thank you. Well, the third presenter is Luan Rodriguez. Luan, are you there?
Hi. Hi.
Hi, Luan.
I am.
Luan is from Brazil as well. He's going to present a work on polluant spill containment via flocking. Luan, you have 15 minutes to present your work. The floor is yours.
Okay, thank you. First of all, good morning,
everyone in Brazil, and good afternoon for everyone in Turkey. Here I'm presenting the work developed by Milo Rodrigues, Professors Nadia and Luisa, and it is about the pollutant spill containment via flocking. So here it is our agenda today. We are going through an introduction about the subject, the object of this work, the methodological background, the proposal method, the results, final conclusions, and future works. So here we have a small introduction about the subject, that it is a real significant challenge for the humanity today. Basically, the oil spills around the world, it is a really big problem since they affect severe coastal economies and aquatical ecosystems. And nowadays we have a really big problem that it is the containment methods, which relies on floating bombs. So these methods have some limitations, that it is the reliance on human intervention, the vulnerability to environment effects like winds, currents, and waves, and especially the low time deployment for large oil spills. So this work proposes a way to automatically contain this pollutant in the water. So here we have an image of how the ecosystem it is affected by this problem. Um, and so this work propose the objectives of this work. It is proposed a scalable, stable, and computationally low-cost method for oil containment spills. Um, so here we have a key feature. It is the computational low cost, and other ones, which it is efficiently identifying the pollutant boundaries, and other ones like ensure a reduced convergence time, distribute the agents around the pollutant in a uniform and evenly spaced barrier, and especially encapsulate the pollutant effectively, and also maintain the barrier regardless any environment factors like the winds, the currents, and the waves. So because of the objective of low computationally costs, we chose some methods like which it is the flocking algorithm and the particle swarm optimization, which the flock algorithm will handle the collective behavior of the boys of the swarm, and he implements some special rules like separation, which handles the problem of the boys having collision around each other, the alignment, which makes the flying together, and the cohesion, which make them stay together, go to the center. And also some other extents like chase and approach, which will be responsible to direct a single void to a target, or to approach a target, reducing the speed gradually. Here we have an example of the flocking rules: separation, cohesion, alignment, cohesion, and also the model extensions behaviors for a single void. And now we have the particle swarm optimization that will be responsible for guiding the swarm, the voids, to the pollutant edge. Because here we use the particle swarm optimization as a method to find the edge of the pollutant by using the voids as the particles of the algorithm and the pollutant concentration in the water as the objective function of our method. So here we have some how we create the voids. So the voids are autonomous surface vehicles which are equipped with a short segment of that boom we talked about later in this presentation. So they have some distinctive radios like the perception radios, safety radios for collision avoidance, and uh, the size of the separation in the barrier, the length of the arms with the probes, and the size of the body's probes. So each void has 9 probes. 8 of them are around the void, and one it is situated in the body in the body void. So they also have a limited internal memory, so they can store the position they detect the water, so they be able to maintain that position. Here we have the conception representation of the voids. Now we have a number overview. So the swarm, it is deployed in the water. They know, they have a prior knowledge of the approximated center of the pollutant, but they don't know where is the edge of the pollutant. So the objective it is to locate this barrier, the boundary, and encapsulate. So there are also some parameters like the number of the voids to be defined, the safety and perceptive radius, the concentration threshold, so the voids can know if he is in a pollutant area, and other some moving dynamics constants. And the algorithm runs until the pollutant barrier it is fully formed and stabilized. Here we have our first rule that it is the border detection. Basically, it works by checking if one of the probes of the external probes are detecting the pollutant and the body probes doesn't detect anyone. And he also makes that position where he found the edge of the pollutant available if there are less than 3 neighborhoods around him. So basically this situation here. So the voids need to keep the barrier stable during the execution of the algorithm. So there are some ways to make them do this. First of all, it is to record the first position where they detect the pollutant. The second one, it is approach the nearest neighborhood in the boundary if he is alone inside his safety radius, and also exit the barrier if there are more than 2 direct neighborhoods around him to avoid overcrowding, and adjust the position in the barrier continuously to keep the uniformity of the barrier. So here we have some force combinations. The flocking rules are responsible to make the collective behavior. The PSO guides towards the pollutant edge, and the barrier stabilization it is when the standard deviation and the variance of the distance between the voids in the barrier falls below a threshold. So here we have our experimental setup, which was Intel Core i5. This is 16 gigabytes of RAM. The pollutant sensing was based on RGB values. Each experiment was executed 150 times for statistical analysis, and the initial configuration of the agents were varied during the different experiments. So here are some examples of the pollutant patches. Shapes, some of them were traditional shapes like triangles, squares, and circles. The others were abstract shapes, like this one in DF. So about the results for the geometric shapes were very interesting, since we could realize that the most difficult shape was the square, since they have some difficulty to disperse the agents around the sharp edges of the square. But also it happened with the triangle, which had the short average execution time of all. And the circle had a good performance and uniformity in the agent's distribution. Uh, so here we have some of the results for different launch sites, different executions, and execution time in seconds. We can see that the square was the worst of results, the most difficult shape. Now moving to the abstract shape, we could realize that the structure, the complexity of the shape directly influence in the performance of the algorithm and also the launch site location. So the abstract shape one had the highest average time, and the abstract tree was the great of all in terms of execution time, since their shapes were their shape was slightly more easy, less complex to contain. The the launch sites, it, the optimal launch size strategy was with 4 different locations, since the bots could divide the work in 4, so they could contain very fast. We also made some simulation videos. If we have time in the end, I will show you some of them. And also, here are some iterations around the shapes with the abstract shapes with different launch sites. So the conclusions that we had was the proposed swarm intelligence approach using flocking and PSO was effective affluent containment strategy, and also scalable, which was proven when we varied the type of shapes and the launch site's location. So also that more regular shapes were easy to reduce containment time. Some future works, we can see that they perform optimization of the algorithm to reduce the algorithm execution time, validation with the different methods in robotic simulations, parallel execution in some robotic simulators like Gazebo, and also adding environmental factors and to apply different forces to the bots. And also a better statistical analysis compared to different algorithm algorithms existing in the same subject. So thank you all for your time. And does anyone have any question?
Can you show us the simulation, please? You have some time.
Okay. I will be showing this simulation here. So we have the abstract shape 2 with two different sides, two different launch sites locations. You can see the bytes getting out of the barrier to prevent overcrowding and also adjusting their position as the algorithm runs. So we have the conventions. Let me see. They have some difficulty to find the displays, but eventually they will find, since the PS code guides them. Okay. So that's some of the simulations. I will be sending the link in the chat, so anyone can see it.
Okay.
All of the
Okay, thanks, Luan.
Thank you so much.
Any question? The question?
Just for curiosity, can you hear me?
Yes, I think so.
Listen. Yes?
Yes.
It behaves like the immune system.
Immune system?
Yes. When you have a strained body and the immune system start to have you tried thought about something like that? Or there is no meaning of what I'm talking.
I couldn't hear.
Louise is saying it looks like
the immune system.
The behavior of immune system.
Oh,
have you
okay.
checked something like that?
Not yet. But for it to work, I will be doing this analysis.
No question? Well, you have a lot of voids, extra voids after caging the spill. Do you think you can control the number of the voids that are used so you don't have so much extra voids?
Yeah, we could estimate the size of the pollutant patch, and basically based on the size of the containment boom that each void carries, we could dimensionally the number of the voids that we will deploy in the water, or we can deploy more, and once the algorithm is completed, we can make the other ones return to the base, basically. It is also an option.
The first option, estimate the perimeter of the patch, is impossible because you don't have knowledge about the spill.
Yeah, Yeah.
We have to try the second one. Okay. Thank you, Luan. Thank you.
Thank you so much.
Just thank the speakers. Thank you. Now we have another, but this one is in presence. It's Maria Carla, Maria Benese. Maria Carla, construction of World Heritage tendency processes. It's a little bit different from the works that are presented now. Elements for systematic profiling. You have the floor for 15 minutes.
Thank you. Devo spostarmi. Sì, prima. No, no, figurati. Ti vuoi sbagliare?
Ok, sono circa attraverso al fratello, esatto. Sì. Con gli ausili. Cosa voglio per sempre come that works for the virtuals. It doesn't work for the. I'm from
Nella modalità sperimentale.
Io prima avevo messo in modalità lettura.
Modalità lettura?
Sì.
Ma dove animata?
Però infatti non è.
Aspetta. Sorry for the delay.
Done.
Sto presentando.
No, grazie. Okay. Thank you for being here. I'm Maria Carla Saliu, a PhD student from the University of Cagliari. Today I'm presenting to you part of our work, which is this contribution, which is part of my wider research project. Co-authors of this work are my two supervisors, Professor Ivan Blecic from the University of Cagliari and Professor Salvador Anton Clavé from the University Rovira e Virgili of Tarragona. Today, I'm going to give to you some information about the context of my research project, and then I'll focus on the aim of this contribution. I present three different sections about method, the key elements, and an application to a real ongoing case study, and then I'll finish with the discussion and conclusion. About the context of this work. The context is my ongoing doctoral research, which focuses and reveals the mechanisms embedded in policy processes regarding candidate World Heritage sites or sites which are already part of the World Heritage list in the context of the World Heritage system. The two most important requirements given by UNESCO in these systems are the outstanding universal value and a management system that must guarantee the protection of that recognized outstanding universal value. The aim of the contribution I'm going to talk to you this afternoon is to examine how, during the nomination processes of this cultural heritage for the World Heritage List, the value of heritage itself is constructed and validated by a narrative which is the proof of its outstanding universal value. In doing so, we adopted an agnostic approach, according to Bruman, which is a third path between the idea of having, between the idea that heritage has an a priori value and the idea of having a foundational doubt about the value of heritage. The method, we first analyzed the UNESCO's constitutive documents in the frame of the policy processes, analyzing some key concepts such as authenticity, integrity, the outstanding universal value. Then we had a direct involvement in different ongoing projects, both of candidacy and of management within the World Heritage System. And we analyzed the data after this direct involvement and after this direct observation from qualitative interviews that we conducted together with key actors involved in that processes. Finally, we did a reconstruction of the policy process of the different case studies. And today I present to you one of these case study, just a part of it. In doing these different steps, we identified some key elements divided into two categories. The first one is related to time. As we are talking about policy processes, we have an embedded time dimension in these processes. So we identified three different phases. The first one, which is the ex ante, regarding everything that happened mainly at the territorial level before having any formalized step within the World Heritage System. Then we have a during phase, which is the phase during which the nomination and the preparation of the candidacy happened. And then if the candidate World Heritage site became part of the World Heritage List, we have an ex post phase related to all the mechanisms of management and monitoring in order to protect the recognized outstanding universal value. The second category is about triggers, and it involves three different key elements. The first one is about the agents involved in the different phases of the policy process. The second one is related to the requirements which are given by UNESCO. And the third one is about narrative, which is not only the way the outstanding universal value is described, but also is the validation and the legitimization of that outstanding universal value identified within the nomination file. Let's now move to an ongoing case study, which is one of the three case studies of my research. We are in an Italian case study in Sardinia, which is an Italian island, where the Nuragic civilization emerged in the early Bronze Age around the 18th century before Christ. This civilization didn't let any written documents, but the only traces we have about this civilization are the monuments, which are all spread all around Sardinia, but we have an undefined number of these monuments in Sardinia. According to Giovanni Lilli, which was one of the most important archaeologists studying this kind of heritage, there are 7,000 of Nuraghi, which is the name of this kind of monuments, not including those that have been destroyed. In 2020, this kind of heritage that we can see in these pictures from different parts of Sardinia started to be the focus of a vision of someone in Sardinia who decided to start to have a vision of regeneration about this kind of heritage in order to achieve not only the protection of this kind of special heritage and monuments, but also for achieving a local development project for all the island. This person is someone that in the frame of this research we refer to as M1. So trying to explain how this process started, I'm now going to tell you how the first phase, the ex ante phase of this process started. So this agent, the first one present at the very beginning of the process, this M1, was the father, let's say, of this idea. And in his initial idea, the neuralgic civilization could be an important factor in achieving an overall growth for the island. In that moment, we don't have any requirements because the UNESCO and the World Heritage process was not his first idea about how to obtain this overall growth. But then he started to think that maybe the World Heritage process could be a good opportunity in order to achieve the goal that he first had in his mind. So another agent was involved in that process, this MU, and together M1 and MU started to think about the vision that they had to create in order to create the tentative list submission format, which actually is the first official step in order to start our World Heritage process. So the idea of these two different agents was related and focused on the extraordinary neuralgic civilization in its traces on the contemporary Sardinian rural landscape. So monumentality in the physical, as a physical dimension in that moment, was just one of the features of this narrative, but not the principal one. After this moment, these people started to share this idea with other agents. I forget to say that M1 is a former politician at the regional and national level, and MU is a scholar, an academic professor. So they started to share this idea, and then they create the first formalization of an association, which was with people that were in their surroundings. And this association was the official promoter of the candidacy process. With the association started the work of preparation of the tentative list submission formal. We are in a phase of formal mobilization at the local level. The narrative was quite the same of the previous slide I was showing previously. But in that moment, they started to involve the other agents in this process. The Sardinian universities as the main experts in subjects such as history of architecture or archaeology, and the Italian Ministry of Culture, because the responsibility of the submission of this tentative list submission format is at the national level. So the Italian Ministry of Culture is the responsible for that submission. In that moment, the narrative about and the focus about that candidacy started to change, because previously we were talking about the extraordinary neuralgic civilization, let's say in general. But in that moment, with the involvement of the Italian Ministry of Culture, the narrative was structured around a candidate serial and material site, which means a site made by two or more components of neuralgic monuments, with each component contributing to the potential outstanding universal value reflecting the importance of the neuralgic civilization. So we started the process talking about an undefined number of monuments all around Sardinia. The number was not an important feature because the idea was more about the immaterial value of that civilization, and the process in the ex ante phase ended up with a selection of 32 monuments of this neuralgic civilization. And these 32 different components are the components which are within the so-called neuralgic monuments of Sardinia, which is the title of the proposal which was submitted in the Italian tentative list in 2021. And with this submission in the Italian tentative list, the ex ante phase officially ended and started the during phase. But today I'm not talking to you about this phase, which is actually right now an ongoing phase in that process. So in conclusion, we can say that this reconstruction of this case study through the different key elements, it's something that allows us to say that the definition of the value that we saw through the definition of the different narratives in different moments of the process is a social construction made by the involvement of different agents in different moments with different narratives and with different requirements to fulfill. And this construction is the one that enables the creation of meaning and making of significant value in the UNESCO context. The key elements that we identified and presented in this contribution should be now extended so that a more general framework of reading this kind of policy processes can be carried out. And finally, this reconstruction adopted an approach that encompasses a dialogue among different disciplines, like the restoration theories developed by Cesare Brandi and key concepts related to the storytelling practices used for the design of content-oriented visitor attractions in the content of tourism destination. I finish my presentation, so thank you.
I'm not from this, I'm not an expert on architecture, but this is just to fill in the time, right? Where your contribution entered in this process, yours, as a research project? Yeah.
Actually, I have to say something. I am directly involved, for example, in the are you referring to the process that I was showing today, the case, that one?
Yeah.
I am directly involved in this, in that process because with the university, with my university and with other colleagues of my university, we are actually working on that candidacy process. So this is one, let's say, direct involvement that I have in that process. Mm-hmm. But in the different contribution that I was showing today here, my contribution is that even if I'm working in some specific aspects of that process, as a researcher, as a PhD student, I'm also I'm trying to analyze all the process from the very beginning, also in the different phases I was not involved in at the very beginning. So I started to not only to analyze the official document about that process, but I also did many interviews with different key actors that were involved from the very beginning as M1, for example, in that process, which are still involved in that process. And with all the information and the data collected from these interviews, I'm reconstructing the process in the different phases, in the different, let's say, most important moments of the process, in order to have an overall framework which is able to explain how in the different moment, in every different moment of the candidacy, that value, that outstanding universal value was constructed, framed, changed in order to correspond to the requirements given by UNESCO. And
are these requirements? Is there, for example, carbon analysis to say that monument is old from that period of time, or some formal proof to validate the candidacy for World Heritage?
Actually, the first requirement is to have and to prove that you have in a written document that site you are going to candidate to the World Heritage List has an outstanding universal value.
What is that?
This is a very good question. Thank you. The outstanding universal value is is the value of that heritage, which explain how and why that site, that specific monument, manufact, has not only a general value, but a value that at the very international level is outstanding and universal, which means that is like a paradigmatic monument for all the world community, let's say. And that value should be proved by a document in which you have to prove, to describe how the site is made, which is the authenticity, the integrity of the site, and which is this, let's say, this special value of that site, which is something that exists just there and not in other parts of the world. So in the case, for example, of this case study I was presenting today, which is a serial site, which means a site composed by 2 or more components. So in this kind of site, we have like a territorial dimension, which is very important. You have to prove that all the components which are part of that site, all of them are important, fundamental for the description and for the proof of that outstanding universal value, which means that one component is part of the selection, let's say, but only that component and the other one, which are the selected one at the very end, are the only one proving that that value that you are constructing, so you are writing, let's say, during the process, are the only one capable of proving that that value is validated and correspond to the selection that you are doing. I don't know if I.
No, I just pushed. It's kind of proof for me that there's no number involved in this process. No, at all.
No.
So when you talk about proof, for me, proof is, for example, you prove that this is old from that age, and you make some chemical or geology experiments to say that this is very old, this is heritage of the world. But it seems that the process doesn't involve any of this kind of process.
No, actually, yes.
Absolutely.
Yes. No. In the document that you submit in the so-called nomination file, you have different sections. UNESCO in the operational guidelines give you all the information about the different sections you have to fulfill and to put in that document in order to describe every aspect about the exact date of that when the monument was built, and all about the authenticity, so that material is the original one or is not the original one, and you have to describe all these aspects and to say why all these aspects are proving yes of that recognition.
I thank you for the explanation.
Thank you for the question.
Okay. So, presentation, but I don't know if the presenter is here. Is another Maria? Maria is here. No?
Yes, I'm here. Good afternoon.
Oh, it's online.
Hello.
It's in presence. So, Maria, you are online, right?
Yes.
Yeah, okay. So, all right, you can share your presentation.
Yes. Just a minute.
So, Maria is going to present to us digital tools empowering tourism development, a business intelligence platform for Basilicata regional growth. Right? I guess that Maria is Italian as well. Yeah.
Do you see my screen?
Yes, we can see it.
Okay, thank you. So thank you for your gentle presentation. Okay, so in the last 10 years, tourism has grown a lot, also thanks to new technologies. Today, it plays an important role in the economic development of many regions and countries. Digital tools like apps, websites, online services changed the way people travel. They help improve the experience for tourists, support better marketing strategies, and help regions grow through technology and innovation. This process is called digital transformation and helps companies and governments make better decisions in tourism. Because of these changes, the idea of digital tourism has become more popular, not only in real life, but also in academic studies. For example, if we search the term digital tourism on Scopus, we found the paper number is growing every year. To use digital tools in tourism, firstly, we need a strong base of digital knowledge. This means having good data and information about the tourism sector. Many tools and technologies work only if this data is available. Because of this, many national, European, and global organizations have started creating laws, guidelines, and projects, as you can see in this slide. However, not all areas are ready. Some regions still have poor digital tourism, mainly because they don't have the necessary data or digital knowledge. This is a big challenge that needs to be solved. In the tourist sector, different types of data are needed. We can look at digital tourism from three main perspectives. The first is the tourist perspectives. Here, the goal is to improve the tourist experience by using digital products and services like mobile apps, virtual tours, or smart guides. The second point of view is the operator's perspective, and this focuses on helping business in the tourism sector, and it includes things like creating digital services, digital products, using data to improve business decisions. And finally, the social development perspective. This one is more general and it looks at how digital tourism can help the development of a region or a community, for example, by bringing more visitors, creating jobs, or supporting local culture. Now let's focus on Basilicata, a region in southern Italy. It is considered a less developed area by the European Union because its economy is weaker than other parts of Italy. For example, the GDP per person is less than 75% of the EU average, and there is more unemployment and lower access to services. Because of this, Basilicata receives support from the European Regional Development Fund. This fund helps reduce differences between regions and improve life in disadvantaged areas. In Basilicata, this ERDF is organized into main goals, and these include innovation, digital agenda, better transportation, energy education, social inclusion. Tourism and cultural and creative industries are also a big focus. One of the most important events for tourism in Basilicata, known for its slow tourism with small villages and natural landscapes, was when Matera became the European Capital of Culture in 2019. This brought a lot of visitors, but after the COVID-19 crisis, tourism started to recover. In this context, Basilicata was founded by the European Regional Development Fund under the axis focused on research, technological development, and innovation. This co-financed the project Basilicata Heritage Smart Lab, where the goal is to support the region's economy by working together public institutions, research centers, and private companies. One key part of the project is the Intelligent Tourism Analysis Smart Lab, and this part of the project will develop the digital platform to manage tourism in the region that I'm presenting. Right now, Basilicata did not have a tool like this, so there was a strong need for it. Business intelligence is a group of methods, tools, and technologies used to collect, analyze, and present data. Its main steps are do heterogeneous data collection, the data analysis task, and construction, and most of all, a construction of a dashboard to visualize results and reports. This is the Basilicata tourism architecture, composed by different levels. You have 4 seconds to look at it. So I count 4, 3, 2, 1. Okay, in Basilicata, and let's go to the dashboard. Basilicata tourism data were originally spread across many different databases and sources. So the first step of the project was to collect all the useful data in one place to better understand tourism in the region. Some of this data needed to be cleaned or adjusted. For example, sometimes data had to be aggregated to protect people's privacy. Also, some indicators were created using the basic information. All the final content is now available in one dashboard, which helps to view and explore the data. We have 2 sections. The first shows historical data. The second section focuses on spatial data. The first section of the dashboard uses only numerical data and graphs coming from the Italian National Institute of Statistics. This data cover tourist arrivals and overnight stays in Basilicata from 2015 to 2021. They are organized monthly and can be explored by NUTS 3 or NUTS 2. Arrivals is the number of people who checked into hotels or other accommodations, and overnight stays means the total nights they spent there. These two helps tourism managers understand the trends in tourism demand over time, allowing comparison over time and to compare Basilicata with other regions. In the dashboard, you can filter the data by time period, territory, visitor type, and see pie or line chart for this information. In the dashboard, it is possible to see a bar charts that show tourist arrivals or overnight stays for each municipality. There are also 3 more bar charts that help us understanding tourist trend, do comparison over time, understand when and from where people are visiting, by year and origin, by month, by year, and Italian regional origin. From the arrivals to presence, we also calculated many indicators: arrivals to resident population ratio, international arrivals to total arrivals ratio, tourist saturation index, average stay, gross hotel bed utilization, net total bed utilization. These indicators help us measure how efficiently, for example, hotels use their capacity, and we can also compare Basilicata with other regions. The spatial section is based on a WebGIS system using GeoServer and OpenLayers, and the background map is from OpenStreetMap. There are 2 main layers: KPI with polygons that follow the municipal boundaries, and KPI POI with points showing key performance indicator for points of interest. In the top left panel, users can select the indicator and tourist origin, national, international, or total, using a drop-down. In the top right panel, the system shows the top 4 municipality and the legend of the selected data. Clicking on a municipality opens a window showing its name, data values, class, and monthly, and the daily histogram for overnight stays. In the lower left panel, you can choose a time period and compare its trend with the whole region. And a similar approach is used for point data. In this section, there are also mobile network data, arrivals and overnight stays day by day that can be filtered by origin, gender, and age group. Lastly, we also have credit cards and transaction data to understand how much tourists spend, where they spend, and what they buy. Other data in the platform are internet data, social media, and search engine. These online sources were used for a sentiment analysis that helps understand how people feel about a place by analyzing online content like posts, comments, reviews, etc. Natural language processing tools were used to clean the data and correct mistakes, and the sentiment was then mapped at municipality point of interest level with 5 levels of judgment, such as very positive, neutral, etc. In the dashboard, users can also see a sentiment score measuring tourist satisfaction, a bar chart for each social platform, a bubble view comparing post volume with sentiment trends, and we also collected reviews and star ratings for each point of interest. For some specific layers like sentiment and number of reviews, there's a third more detailed level. When you select these layers from the point drop-down menu, a small grid icon appears, and by clicking this button, a 1 kilometer grid overlays the map. Each cell in the grid shows the average value of the selected data, for example, average sentiment or review count in that small area. And this allows us to zoom in and analyze data at a very local scale, giving us more precise insights into what's happening within neighborhoods or specific tourist zones. Okay, here I listed many advantages of the platform, such as centralized access, smart visualization, insightful analysis, support for professionals, strategic planning, resource allocation, capacity analysis, retention and satisfaction. And I identified some limitations and future developments, such as we have limited data over time, but this is always extendable, forced aggregation for privacy in small municipalities, the binary gender profiling of data, but this is not our fault, data are made in this way. And for the future, we hope to be able to continue the project and to have a multidimensional instrument for data synthesis. If you are able to check other limitations, I'm here for any questions. Thank you for your listening.
Thank you, Maria. Any question? Someone wants to help a little bit? No? Maria, your title, I'm not an expert in tourism, right? But correct me if I'm wrong. You say that this is a smart lab, right?
Yes.
Except besides counting things, making statistics, do you infer some new data, or do you learn something new that is not present in the data?
Yes. Yes. Because, for example, before to have the platform, we think tourism was concentrated in particular periods of time and in particular cities. But then we saw that also minor countries have a good level of tourism impact. So, for example, we understood that also these small countries have a good importance to, and they need to be improved and to concentrate their strategic policies in regional tourism.
Okay, all right. Thank you very much. Thank you. Okay, that's all. Thank you, speakers. Thank you very much, all the speakers, all the presents. And that's all for the session. And which one for the day? And tomorrow is another day.
So session is over?
Yes.
Okay, we can. Good evening. We can close this session. Thank you all for your participation, for your contribution, and see you in the next days, and enjoy your ICCSA conference. Have a good evening.